Okay, so this is the fourth and final equation that we have in the book from chapter 6. So from chapter 6 we have an equation which is called Snell's law. This equation is used to find the angle of refraction. For angle of reflection we use the law that was called the law of reflection, which whatever your angle of incidence was, the angle of reflection would be the same thing. For example, if you have light traveling from one medium into another medium with angle of 25, let's say, the angle of reflection will also be 25 according to law of reflection. But in refraction this is not true. In refraction we cannot use the law of reflection. For refraction we have to use another law. In order to find the angle of refraction we use a law that is called Snell's law. And this is how Snell's law looks like. Let me actually share the screen. Yeah, this is how Snell's law looks like. And let me go to my pointer. Alright, so law of Snell's law has four variables. This is variable number 1, Ni, which means the index of refraction for the first medium. Because in this case, like in a case like this, light travels from one medium into another medium, and the mediums are transparent, by the way. So anyways, light travels from the first medium, which has an index of refraction. This is the incoming index of refraction of the first medium. That's why we call it I. Then the second variable that we have is the first angle, the angle of incidence. This is the angle in which light goes into the second medium, right? So this will be the angle of incidence, the angle of incoming light. So this is the second variable. The third variable in this equation is Nr. This is the index of refraction for the second medium. For example, if light comes from air to water, the air will be Ni and the water will be Nr. And knowing these values, the N, the index of refraction, knowing those values is given in a table from page 144. Alright, so that's the three variables that we have. The last four variable is usually what is unknown in the book. Like almost all the questions that we solved, theta r is unknown. So in this video I'll only find the case in which theta r is unknown, and theta r is the angle of refraction. Angle of refraction is found through Snell's law. This is the law, and we find theta r. So let's have a question in which we have everything except for the angle of refraction. So let's find angle of refraction. This is an example. It says if light passes from air to water at angle of 30 degrees. Alright, this is the angle, 30 degree. It says find the angle of refraction. I cannot use the law of reflection because this is refraction. In order to find the angle of refraction, which is theta r, I need to use another law which is called Snell's law. I just explained Snell's law for you, and this is the equation. Let me first write down the equation and then I'll insert the values back in. So Snell's law says Ni multiplied by sine theta I equals to Nr, this is the index of refraction for the second medium, multiplied by sine theta r, and theta r is the angle of refraction, which is unknown in our case. Sine theta r. Okay, so what is the Ni? Ni, this is Ni, the air, right? This is Ni, and for air, according to the table on page 144, the Ni for air equals to 1. It simply equals to 1. So instead of writing Ni, I'll just insert the value back in. I'll insert 1. Then multiplied by, because whenever you have an operation which is invisible, that means this is a multiplication. That's in mathematics. So then you have sine theta I. And what is theta I in this case? The theta I is the angle of incidence, the angle that is given. This is theta I. So I'm sure a lot of students, at least a couple of students, I'm pretty sure in the exam will make this mistake. They will just say 1 multiplied by 30. That's not correct. What about the sign? You shouldn't leave out the sign. You have to insert the sign as well. Okay, so don't say 1 multiplied by 30. Say 1 multiplied by sine 30. Okay, because 30 is different than sine 30. Don't make this mistake. The sign is also relevant. The sign is also important. Alright, so 1 times sine 30 equals to Nr. What is Nr? Nr is the second medium, which is water. Okay, and NR for water, according to the table that we have on page 144, is 1.33. This is the index of refraction for water. So I'll put this value back in, 1.33. Alright, and then I don't have theta r, so I'll simply write down sine theta r because I don't have that. This is my unknown. Now, how to isolate theta r? This is unknown, so I need to isolate theta r. Whenever you have your unknown, you have to isolate it in order to find it. So this has to stay alone. Now theta r has two partners, two unknown partners. The first one is 1.33, the second one is the sine. So I have to get rid of both of them. How do I get rid of the first one, the 1.33? Of course, this is a multiplication between them. So if I want to get rid of a multiplication operation, when it goes to the other side, it becomes a division. So this goes to this side and it becomes a division, 1.33. And because it went to the other side, this one of course disappears, right? And the second annoying thing that is next to the theta r is the sine. Sine, you cannot just simply divide it. For sine, in order to get rid of it, you have to take sine inverse. And so this, you have to take it to the other side, and once it goes to the other side, it becomes sine inverse. So I'll have sine inverse here. This is how sine inverse looks like. Sine to power -1. And put this in bracket, just to be nice and clean. And there you go, you have theta r. So theta r equals to sine inverse of a bracket, which you insert the values back in and you will get the number. And the way you use the calculator for sine inverse is you press shift and then sine, and you will get the sine inverse. Just in case you don't know how to use the calculator, press shift and sine, you get sine inverse. And then a bracket will automatically open up for you, and then you will put the values back in. 1 times sine without shift this time, because this is normal sine, this is not sine inverse, so you don't need to press the shift, only press sine. 1 multiplied by sine 30. Then press divided, press the division, 1.33. Once you're done with that, close the bracket. Don't forget to close the bracket, because I'm afraid that sometimes some calculators will create problems for you in these cases, so close the bracket. You can see the bracket closing on the calculator. Once you put that, press the equal button on the calculator, and you will get the value. For this case, if I insert all these values back into my calculator, I'll find the theta r, which equals to, I guess it's 19 point something. Let me see, what is it? This is the same example as the, is it the same example as the sample problem? No, it's not. So I'm really not sure what do I get. It shouldn't be 19. I'm not sure what should I get, but I know it's different than 13, because angle of refraction is not the same as the angle of incidence. Angle of reflection on the other hand is the same. For example, if the question tells you find the angle of refraction, okay, this is what you do. You use the Snell's law. But if the question tells you find the angle of reflection, not refraction, reflection, okay, with L, not with R, then you don't need any equations. You don't need anything. You only need the law of reflection, which tells you that the angle of incidence, 30, equals to the angle of reflection, which also equals to 30. So I may ask you, find me the angle of reflection, find me the angle of refraction. For angle of reflection, you don't need equations. You just solve the question according to the law of reflection, which says angle of incidence equals to angle of reflection. 30 equals to 30, 40 equals to 40, and so on. As for angle of refraction, theta r, you need to use Snell's law, and this is how Snell's law is used. Alright, so that's it. This is all the 4 equations that we have in the book. Watch study these videos carefully. Try to use different variables. For example, like here I used 30 degree. You try to use 40 degree, 45 degree, so that you get handy at it. I wish you good luck. I'm sure that the equations are easy, the questions are easy. Good luck, and hopefully you'll pass to next year safely. Have a good time.